All right, looks like we're live. Thank you everyone for joining our wrap-up session and for participating in the bootcamp. Quick reminder to please take a moment and submit the bootcamp feedback form. If you haven't already, we really appreciate that. And it's a great way for you to directly influence the direction of Snapps and SnarkyJS. Today, we're gonna have a number of sections. Most of these are gonna be very brief, and then we're gonna spend most of the time on the project discussions. We want to give you a glimpse into the future of Snapps, some upcoming features, talk about the Snapps Builders program when the results will be announced. And then the longer portion of this will be the project discussions where selected individuals will get a chance to, or not selected, but for today, so this is different from the Builders program, but certain individuals will get the chance to show and discuss their code, which should be pretty fun to learn from. And then very briefly, some next steps if you want to continue your journey with Snapps. And then we'll open up to a Q&A for anything you'd like to talk about. Okay, future of Snapps. In addition to our Snapps public testnet that we have planned for early 2022, we have some exciting things planned, and we want to give you a preview of these. Some upcoming features: the ability to support custom tokens and NFTs. Should open up a lot of different use cases, particularly around DeFi. We'll also be adding support for off-chain storage in the future, which will allow your Snap state to be potentially unlimited. And then within the on-chain state, you could just store the roots of a Merkle tree or the data for a Merkle mountain range. And also, we'll be adding support for on-chain sequencing, which is actually really cool. It allows for the ordering of concurrent transactions that modify the state of a Snap account. And the reason this is important and super cool is because we have off-chain execution. So it's really important to have something to handle that and to help address state race situations. So that's pretty neat. Another big project that we have underway is called ZK Oracles. You may have heard of us refer to this as WebSnap previously. It now has a new name. And this allows you to consume data from any Web2 HTTPS websites as a data source for your Snap, and to do it in a private, cryptographically verifiable way. When a ZK Oracle runs, it would run on the user's local machine. So they could fetch data, or your smart contract as a Snap developer could fetch data from a private data source or a private API, and it runs locally on the user's computer, whoever's using your smart contract. So you can actually maintain privacy for that data. So will open up a bunch of different use cases. And then also there's another company in the Mina ecosystem that is working on an Ethereum bridge. And this will allow Ethereum to interact with Mina and leverage Mina's capabilities. So one example use case would be an Ethereum DAO, where you could use Mina to provide for anonymous voting. Another example use case would be, there's so many, but you could mint ERC20 tokens on Ethereum based on the results of a Mina smart contract or data received from a ZK Oracle. So for instance, cryptographically proving crypto asset balances or trading performances, even from a centralized exchange, using ZK oracles and doing it in a cryptographically secure way. So that's pretty cool too. And of course, with all this new tech, with zero knowledge based smart contracts on a layer 1 blockchain, scalable off-chain compute, off-chain storage, and then private trustless ZK oracles, it creates many new opportunities of things that you as a Snap developer could create. And we're really excited about this. Of course, at O1, we're focused on building the tools to make it possible, but we're really excited to see what the community will come up with as far as use cases. And so a few things that we're excited to potentially see in the community would be private asset transfers, private asset verification, private reputation or ID, anonymous voting, layer 1 zero knowledge rollups, and potentially a world of use cases that are compute intensive, but are viable on a model like Mina because of the off-chain execution. So we're really excited to see what the community comes up with in the future. And then I'm going to pass it to, oh, actually, I'll take this one for pass on to Brandon. So the Snap Builders program, just as a reminder, selected participants will be awarded 10,000 USD in Mina and have the opportunity to work in close collaboration with Owen Labs and the Mina Foundation as you develop a snap. And if you have questions and want to provide feedback for improving SnarkyJS, we're really looking forward to that. We'll need some time to review the projects that were submitted. And so we anticipate announcing the results of that in a couple weeks. And we mentioned the criteria previously. Okay, now I'm going to pass it to Brandon so we can do the fun stuff and discuss projects.
Hello. Yeah, so I actually, before I jump in, I'll just answer one question here. A use case for on-chain sequencing. One thing that you could do is if you have a Merkle tree, so in your state you have a Merkle root, every time someone wants to update that state, the Merkle root would change. So by default, you'd have this problem where only one person could interact with the smart contract at a time, and because it's off-chain, you don't know what the new Merkle root is. But with this on-chain sequencing feature, you can have multiple people submit updates to a Merkle tree at the same time and be able to process them. The way it works is complicated enough that we need to like flesh out a really nice API, write documentation. So cool. Yeah. So the project discussions. The way that we're going to do this is first I'm going to ask a few folks to come up to the stage and just give like a quick 2-minute talk about their project. Maybe I'll give a couple notes on it as well, and then at the end of those, I'll give a few shout outs to other projects, and then we'll move on to the next part of the presentation. So if you want, okay, so I have people's preferred public names. So QComps, if you will raise your hand in the chat. I think I saw you. So that and then Regina can add you to the stage. So while we're waiting for that, this QComps project is a game called Blank Slate. So yeah, it's for Regina. It's Kobe in this chat. Okay. Hello.
Hey, can you hear me?
Yeah.
Cool. Yeah, so I don't know if I'll tell you about the game. So it's called Blank Slate, like you said. The sort of key conceit of the game is you get a prompt that's a phrase with a word missing, and the different players guess what they think the word should be to fill in the blank. So I think an example was, my favorite animal is blank. So each player submits their guess. Like you might have dog, cat, gorilla, giraffe, dog. And then the way it's scored is you get 1 point for each additional player that guessed the same word as you. So what I did is I did some proving functions, like making sure that you can only guess one time per round. And once your guess is submitted, you're locked in. And your guess gets hashed onto the chain with your player index, which is, probably a breakable way. If you were playing for money, it'd be pretty easy. But in theory, on the hashes on chain won't look the same for the same word. And at the end of the round, someone says, okay, round's over. And it will look at each guess and it will update the score based on who guessed the same words. And then at the end of the game, we can prove that the asserted scores are the same as the scores on the Mina chain and ensure that the highest score is higher than the winning score in the game state, and then determine that a player won. And I didn't handle stuff like ties or plenty of edge cases, but that's how we do in a hackathon.
Awesome. Thank you.
Fantastic. If you guys would, I can stop screen sharing if you guys would like to show some code or anything.
Yeah, I'd be happy.
Oh, yeah.
Let's try to end this.
Yeah, maybe just for like 15 more seconds.
Yeah, I'll literally run the demo code, but I will have to figure out a script to share my screen. Share screen. Entire screen. Hopefully I don't dox anything. And we'll do so I'm just going to run two different demos. It's a 4-player game and a 6-player game. And I think once SnarkyJS loads, it will just log to the console the game as it gets played. Live demo.
Yeah, it's going. Maybe there's a lot running on your computer. It's going pretty slow. Also, I'm happy to present for folks that don't want to share their screen.
Here we go. So I'll let this run and then I'll scroll to the top so you can see what happens. But so here's the 4-player game. You can see like a prompt. I just made that up. Each player guesses. At the end of the round, the scores get updated. And then at the end of the game, someone claims that the game is over. And the code says, okay, let me double check that. Yes, I agree the game is over. And here's the winner. So that's basically the demo. Awesome.
Thank you. And I don't know if it's all right for folks. You can, so Kobe, maybe you can share the link to the repo on GitHub. And I'll just ask everyone to do that. And then, yeah, and I thought, when we reviewed your code, it was pretty good. There were a couple, like a little mistakes that I just want to call out so people can learn. Not like you did nothing, nothing bad. It's our fault for making the API confusing. There's a switch statement in there, and in like the prover in the circuit, and that won't compile correctly. Okay. So like branching has to be handled in a annoying way. So we'll make sure to make that clear in the future documentation. And then the other thing is the things inside the as prover blocks don't run in the verifier. So there's some stuff in the as prover that should be outside of it. But otherwise, this is like a really good example with a couple methods and a unique game. So awesome. Thank you so much.
How do I get out of
here? I guess Regina will dismiss you. There we go. Okay. Awesome. So the next person that I want to invite up here is Florian. So Florian, if you can raise your hand, or maybe Regina, you'll just find them. And while we're waiting for Florian, Florian's game is well, not a game. It's like a DEX that you have to. Oh, you're here. Anyway, you can explain it. Goodbye.
Can you hear me?
Yes.
Perfect. So I'm just going to share my screen. Okay, that is going to be just a second. Okay, that should work. Perfect. Can you see my screen?
We can see it.
Okay, great. So I wanted to go a different route. I didn't want to make a game. So I decided to combine three things. First would be obviously the zero knowledge contracts of Mina. The second thing would be a user interface like everyone knows from other popular protocols like Ethereum. And just to finish that up, I decided to make a feature that everyone knows, which is basically like an exchange, like a token swap program. And yeah, as you can see, I made a little user interface. When you first open up the page, you can see basically a button and a slider. You can use the slider to basically adjust the difficulty of an equation. And when you just deploy the contract, we will deploy the contract and generate a equation. It's a quadratic equation, as you can see right here. And we will use that equation to basically gain access to the exchange. And if we just continue, we will get to the next page. And now we would have to solve that equation and insert a possible solution. And because I don't want to do that by hand right now, I'm just going to insert it into a graph. And we can see that one solution would be 1 and the other one would be 8. So we're just going to insert, I'm going to insert something else now, like 3. It fails because that is not the solution. But if we insert 8, that would work. And just to mention it, on the other side, you have a little hint, which basically is the formula how to solve this equation. But if we continue, we will get to a page where you could swap token. So basically, this is just like a simulated token called proxy and Mina. On the left side, we have a few more information like the equation again, the solution we submitted, our balance in Mina, our balance in token, the contract balance, and just a history of transactions. So we can now swap, let's say 100 Mina for 100 token. That would work. We now have 100 token. We have a small transaction history. We can also just change the order how we want to swap. We can insert an amount again, and we would sell those token again. You can change some accounts. I currently only implemented 2 accounts. And the idea behind this exchange is that you can only access it if you know the solution to this equation. And because the power of smart contracts and zero knowledge proofs, you do not share your solution with the network. So only people who solve this equation themselves have access to the contract. So that is basically a small proof of concept. Everyone can just run it themselves if they open the link. Not sure if you can see it. And it is also available on GitHub if you want to take a look yourself and run it. I made a small Vue.js page for that. So you have a nice user interface. And yeah, that's it. Thank you.
Awesome. Thank you. Thank you so much, Florian. Yeah, super cool. Love the UI. Yeah, thanks for sharing a link to the code. I guess Regina shared it for you. But yeah, so also like awesome, good example. Like mostly working. I think the one thing that would be a little security problem if this were on chain is like checking the public keys doesn't use any sort of like signature scheme or anything. So
yeah, that's true.
Yes, but yeah, otherwise this is awesome. Thank you so much.
Thank you.
Cool. Okay, so next up is oh, by the way, I'm asking the presenters to come up in the order of the submission date. So there's no particular order other than, well, the particular order is whoever submitted first is the one who's going first. Okay. Now Francesco, Francesco is going to talk about Hangman. There were actually a couple of Hangman submissions, and yeah, Tau Lepton is the name for Regina. And this one, Francesco did a great job. So I hope I'm pronouncing your name right. So yeah, I will wait. I need to level up my MC skills in this little blank space between projects.
Hello.
There we go. Hello.
Yeah. Cool. So I'll just share my screen. 2 seconds. Cool. As mentioned, I essentially created a Hangman game. So for those who aren't aware, Hangman is essentially a 2-player game. The first player is responsible for essentially selecting some kind of secret word, and then it's a round-based game where player 2 has to kind of guess a character which is included in the word. If the character is in fact included in the word, then player 1 will kind of reveal where that character lies in the word, and subsequently kind of the game continues through the rounds. If player 2 makes, in this instance we've said 5 incorrect guesses, then player 1 wins. Or if they're able to kind of guess the word completely without exhausting those 5 lives, if you like, then yeah, player 2 wins. So just to kind of illustrate this, I can quickly demonstrate how it will work just via an interactive example. So we'll set the secret word. So this is player 1. So we set it as bootcamp. So the player 2 now has 5 lives to guess. So we'll guess O. We'll guess B, and you can see that the kind of the characters are being revealed iteratively. If we type in Y, we can see that no character is revealed, and the incorrect guess is kind of is incremented. So that's the nature of the game. We'll just complete the game, so you can see that the winner is player 2. You can trust me, or you can try it yourself. That if you get to 5 incorrect guesses, player 1 will win, and player 2 will lose. So if we just dive into some code quickly, first of all, what we need to do is create some sort of mechanism to actually encode strings. So the way that we did this was essentially by creating an array of fields. What we do essentially is we take the string and we represent it as an array of characters, where each character is encoded as a field, and then the character mapping is seen here. So A is equal to 1, B is equal to 2, so on and so forth, and then we've got underscores to kind of represent characters which haven't been guessed. Because we've got 27 characters, these can all be represented in 5 bits, so that's where we get our char size from. And then this kind of array is subsequently kind of serialized into a single field, to be stored kind of as state in the smart contract, at least for the guessed word. The secret word is maintained off chain. So the constructor is essentially just responsible for taking that serialized word from the contract state and constructing or instantiating this class with in which each character is represented as a field in the array. And then we've got some utility methods. So we've got just to instantiate this word class from a string, convert a character to a field, so on and so forth. We then also have some methods for extracting matches. So for example, if player 2 guesses a specific character, we want to find all of the elements in the word, in the string or the word that match that character. Also for kind of updating the guessed word with the correctly matched characters. And then some additional methods for serializing and for output into string. In terms of what's actually stored as state in the contract, we've got the guessed word, so that's kind of incrementally revealed as guesses are made. We've got the prior guess character, so once player 2 makes a guess, that will be stored in the guess character state for player 1 to kind of review. Incorrect guess count, next player kind of Boolean, and also a field to store the outcome of the game. And then we've got some circuit parameters. So these are essentially responsible for storing kind of the guess limit, the word length, player 1, player 2 public key, and the word commitment. So these do not, these are essentially static, they're immutable, and they're actually encoded into the contract or into the circuit upon kind of instantiation or deployment. We've got, this is, I mean, I'm not going to kind of walk through every line, but one of the interesting pieces is this word commitment. So we obviously don't want to store the secret word on chain. So instead, what we do is we combine the word or the field array with some element of randomness, which is passed in by the constructor, and that commitment is stored on chain. We've got two methods essentially. One of them is for player 2 to make guesses, and then the second is for player 1 to check those guesses. So just some basic stuff about asserting that the game is not complete, that it is player 2 trying to make the guess, that it's player 2's turn. We want to verify the signatures, and then subsequently upon all of that, we want to actually submit the guess character. And then the second method is, as I said, for player 1 to check the guess. So basic stuff, assert it's not complete. Make sure it's just player 1 making the guesses, ensure it's player 1's turn, verifying signatures, verifying that the word that has been presented, as argument for this method, and the randomness does equate to the kind of the word commitment that was kind of persisted into the contract or into the circuit when it was kind of deployed. We then take the guess word and find the matches. We update the incorrect guess count. We update the guess word with any additional, any correctly identified characters. We check if the word has been found. So, is the guess word equal to the secret word? And then off the back of that, we assess the game outcome. Has the game been won or lost? Is it still ongoing? And then subsequently, we kind of iterate to the next player. So yeah, in a nutshell, that's it really. In terms of how it's done by the CLI, it's just an iteration over those 2 steps until somebody wins. So yeah.
Awesome. Thank you so much.
Cool.
Yeah, great example, great game. Looks good. And it's really, if you're looking at the code, it's interesting to see your encoding of the words for those developers and audience. So yeah, thank you so much.
Cool. Cheers.
So next up is Jimmy Kim, and Jimmy did an interesting card game, and very ambitious project, but the part that's implemented is interesting. So we want Jimmy to come on up and share. How's everyone's day? Oh, there we go. Okay.
Hi. Yeah, I'll cast my screen. All right. Can everybody see the GitHub? Okay. So the game that I tried to implement is a game called Blind Man's Bluff. It is a type of a poker, a simplified version of poker. So you only can see other person's card and you don't get to see your card. And once the game starts, it has two phases. A main phase is a anti-betting phase, and then a round of betting, and then in the end you find out who won. I thought this was going to be interesting because the smart contract could know who the winner is without revealing the actual number that you got, because it's in your forehead, so you don't know what the actual number is. But during the implementation, I found a interesting problem to solve, which is at the anti-betting phase. So the high level of anti-betting phase is that all the sample codes or the projects that were in samples like TikTok or Stoku had turns of users having to run the transaction, but I wanted to make something that paying the ante doesn't have to be in a certain sequence. So it's very hard for me to explain it in English, but so basically I made a huge circuit which could be run by either users, and the state will always be consistent, whether it's your turn or it's not your turn to run the circuit. The actual documentation is more detailed than what I can explain, so maybe you guys could check it out. I'm not sure if I'm doing it right. I probably would be totally doing something wrong, but yeah. After the anti-phase is done, I named it so that I could remember. It was a turnless betting phase that I tried to implement. And then after that, there would be just like the other samples, like a commitment of the winning hash, but the actual implementation is not there because I ran out of time. Yeah, thank you very much.
Thank you. Awesome. Thank you so much. Yeah. We really like this one because of the complicated Boolean logic that you had. So for people who want to see an example of that, check out this code. Yeah. Thank you so much.
Yep.
All right. So, and then just I won't repeat myself, but just for everyone, make sure that when you're using the public keys, you need to use check signatures to make sure that people are who they say they are. Cool. Okay. Great. Wow. You're here before I even introduced you. So yeah. Anyway, your Mohammed's project is a sealed bid auction. So anyway, take it away.
Okay, thank you. There is actually a huge business where companies can bid as a secretly bids for the lowest or for the highest price, and the reason is this would benefit actually the one who's interested in having the bids. I mean, there is let's say a government entity want to have a tunnel or a highway built, and the companies can bid for doing this project. And to make it more efficient for the government, they're not interested in publicly announced bids. They want every company to bid securely without revealing the bid of the others, and this way would result in the benefit of the government entity for having the lowest price possible, not the others would pricing themselves according to the others. So this is the main idea of the sealed bids auction, and I made a small UI for presenting the idea, and also wrote a small Snap implementation yet to be for sure improved. And yeah, I guess I have lots of places where also the team can later point to me where to fix something that's not appropriate actually. So however, this is the UI. This is the first time we open the web page, so we can choose to deploy this auction. We can say, for example, no one is allowed to bid above 1 million, and the participation cost is 10. So we can deploy. Now it's deployed, and every this is like a dummy actually participant list. But in the real world, it's actually whitelisted people who early provide their papers and provide all the needed stuff for the insurance and all other needed papers, and then they can participate in this. And actually, it's all usually they pay money also to just be able to read the tender paper and what's the project is. So, however, for our example here, let's say the first bidder want to bid for 3,000 bid. The other, let's say, he want to choose 5,000. And this for sure should be happening on a different web pages from different computers. But here it's for the sake of the sample. Yeah, it's on the same web page. Let's say the third would be interested in 4,000. Let's say, yeah, this is interested in maybe 2,500. And let's say this is interested in 6,000. So now the owner of the auction, you can say, can reveal who is the winner, and this is the winner. So Amelia is the winner because of her bid, and we can see also the balances. So everyone actually paid to participate in the bid in the auction, and this one, Amelia, actually she paid to participate, and also then she got the money to do the project. And yep, this is so this is basically the UI. Maybe it's good to see the code. Let me, yeah, open it here better. So just going fast through the code. It's quite simple. I have some properties of the class, of the smart contract class, which is private, and the constructor, I'm initiating them. The bid function is simple actually. If the participant is not whitelisted, then we throw exception. Can do it in this simple way, or just try to throw a meaningful exception message. And also here we check if the amount is less than the lowest bid. So if this bid is eligible to be the winner later, so we save it as the lowest bid, and we save the winner, the public key of the winner. And if obviously if no one else have the lowest bid, then he would be the ultimate winner. And here also we deduct the participation cost from the bidder. The reveal functionality is also simple. Yep, we announce actually the winner, and we pay him. We take the money actually from the balance of the smart contract, and we pay the winner with the money. And this also enforced to be done only by either the winner or the smart contract itself. So we don't want anyone to reveal it later. Maybe it's currently the setup is not very much supporting this idea, but yeah, this should be reviewed and enhanced. But the idea is also that in real world we don't want to give the full control of the winner, because he may be just cheating, and he don't want to reveal later. So in case he didn't show up, the contract owner can reveal the winner, and then if he didn't do the project, then he can be penalized. Yeah, there is just a dummy filling of the list of the bidders and some wrapper functions to call the deploy, passing the private keys of the deployer, and the wrapper also for bid, for the bidding, and wrapper for reveal winner. And here is the React application. I built it on SnarkyJS Sudoku. So thank you for providing it. I just did my change on top of it. I found the license is Apache 2.0. So I made it also as a fork, so the changes will be preserved for the copyright. Yes, thank you.
Awesome, thank you so much. Yeah, super unique, cool example. I think just for folks looking through the code, and for Mohammed, one mistake that we've seen like a lot of people do, and something that we need to find a better way to teach and like make clear in our API. But there's a lot of there's some logic that's just in JavaScript but doesn't end up in the circuit. So then we end up not actually proving the right thing. And similarly, there's some state that is not in like state on chain that should be, and that lets people prove anything. So those are some things that we'd have to change before this went into production.
Yeah, thank you. Actually, it will be
logic. Yeah.
Thank you very much. It would be great actually if you provide some resource where define how to make a public variable, how to make a private variable, how to make it part of the circuit, how to be not part of the circuit. So maybe dedicated article about this would be just great.
That's a really good suggestion. That's something we should do. All right. Thank you so much.
Thank you.
Okay. So next up is well, there's two people, so I don't know which one of you wants to come up and present. But it's Comdex and Coldstar, and they're going to talk about an identity solution. Oh wait, it's Vim. Sorry, did I skip Vim by accident? Okay, never mind. Sorry, Vim is first. Vim is going to talk about a checkers implementation. So this is one of the example games that I talked about last time. Sorry about that, Vim. I actually am a Vim user. I've been a Vim user for over 10 years.
Yes, me too. Unfortunately, I'm not using Vim right now because SnarkyJS like support in the ID, the
VS Code
ID.
Yeah.
Yeah. So.
All right. Good luck.
Yeah. Thanks. So this is it's my first time actually writing any code related to ZK. So excuse me if I'm making any mistakes. Let me share my screen. So do you see my screen? Right. So because of some reason, so one part of the logic in the circuit, it's not it's ultra slow. So I actually posted a message about this on Discord as well. So but I will start it just now at the beginning. So my code is a checkers game. For those of you who don't know, it's similar to tic-tac-toe, or even chess. So you basically have sets of pieces for two players. Initial board looks like this, where there are
Hey, Vim, sorry to interrupt, but actually, so we can see your mouse cursor, and then we just see a black screen.
All right, then maybe I have some problem.
It could be the wrong screen. Maybe.
I am sharing the entire screen. Maybe let me try again. Maybe I've okay, sharing the entire screen probably doesn't work for some reason. Let me just share my ID. Now
now we can see. Perfect.
Okay, now you can see the ID. Okay, so before I was sharing the entire screen, maybe that doesn't work for some reason. All right, then let me start this again. So I'm running it in my console. So yeah, so checkers, for those of you who don't know, like it's a game similar to tic-tac-toe or even chess. I actually based my code out of the tic-tac-toe, the game that you guys presented before. Thanks for that. And it goes like this. So the initial board is like this, and B represents one player, W represents one player, and then you have a bunch of moves being made. As I said, it's a bit slow right now to go through one move, but I also have the actual output here in the README for those of you who want to check. So let me just go through it first. So let's say initial board is like this, then the player one makes a move like this. So all the moves are always diagonal. So so you can see that the B moved here, and then then the next player makes his move, then W goes from here to here, and then you have so like that you go over those moves, and then there is this place where you can actually take over the second player's so here, because of this movement, the player with W, he can actually take over this piece by going over it to the opposite side of B. So here you see that move in the fourth move, and so then the player one loses one piece on the board, and like that the game goes on. And eventually there would be a state where, so my game logic is very simplified, so you basically have to get rid of all the opposite players' figures in order to win the game as a player. So that's the win condition, but there are other win conditions as well. The game can be pretty complicated, so let me just quickly go through the code. So there's so it starts with this piece. So I wrote this custom class, or the circuit value. I think it's required, maybe it's not required. So according to my understanding, it was required. So so there's this class that has a representation of a single piece, and then the board state is basically an array of this piece items. Here you can see this, and it's encoded basically as a like on-chain state is basically an array of these items put together and wrapped in optional. So you can know whether the piece exists or not, as well as what piece it is, and each piece encodes these values, like which player it belongs to. Is the player king? So checkers also has this special logic where if you go to the opposite player's side, like complete the move to the end of the opposite player's side, then your that particular piece is marked as king, and that piece can move anywhere diagonally. It's sort of like a bishop on chess. So that's basically how the board is encoded, and rest of it is pretty similar in terms of how the board is initiated. So here, compared to tic-tac-toe, you also have to have an initial board state, like I mentioned. So that's what it's being built here. And then move function is also interesting. It has this so in tic-tac-toe example that was presented, so you basically have one set of coordinates to actually move a piece, but here you need two sets of coordinates to say where the piece is in the board and where the piece needs to be moved. So that's why there are like x1 y1 and x2 y2, and then there's like bunch of logic to verify. So first of all, to actually get the piece, if it exists, and the place, and then the logic verifies in the circuit, like if the piece actually exists and it has the correct information, and the owner of the piece is the current player, and then the piece's coordinates, and the place actually doesn't have anything already. So in checkers, you cannot move to a place where there is already a piece existing. And and then non-king pieces only can move forward, so that's also there. Like that, there's a bunch of logic, and eventually after all this business logic, it gets to the point where it's moving the piece actually to the given place, and also removing any pieces along the way, that like I showed in the earlier console log. And and then there's this place, which is the place where it got really slow, as I mentioned. So I'm trying to actually get the pieces in between the current place and the next place that the piece is being moved, to remove them, and this logic became a bit slow, so that's why the program is running slow. So I think that's all I had to present.
Great.
Yeah.
Thank you so much, Vim. Something we will definitely take a look at your example and try and figure out why it's really slow with those extra assertions. Because I bet it's something we can fix. But yeah,
thank you very much.
Awesome. Yeah, ton of logic here. So really good job. Thank you so much. And
I guess we need to wait until I'm out.
Regina will handle it. Cool. Yeah, and I'll just stop saying the same things that I've been saying. But if anything new comes up of little errors that people make, I'll mention them, so everyone can learn. Okay, so next up, Comdex and Coldstar did a group project, and I guess both of them are here, so maybe both of them will come up to the stage, and they're going to talk about an identity solution. So while we're waiting for them, some cool projects so far. I'm just filling space, talking. All right. Hello.
Hey, hello. Hey, hello. Let me share my screen. Oh, just wait a second. I mistook some operation. Hello?
We can see your screen. Yep.
Could you see my Visual Studio?
Yes.
Studio code? Okay. Okay, let me try okay, firstly, I have to claim that I am not really good at English speaking, so but I will try my best to make sense. Okay, and our idea is to create a DID platform based on Mina, with based on its feature ZK proof, and let me talk about our idea. We name our project as ZK Pass. And what is this? And it is actually a snap, dApp, a crypto identity dApp. It is only based on Snap smart contract, but also an ID authenticator. But I have to claim that it is a pity that because of the time limitation, we cannot carry out all our pages. So I cannot share our project as an entire project. So, but luckily, we made our project. We made some pages. We made some pages. We made some picture about our pages, about our design to share here. So I think these are enough for me to share to make sense. Okay. ZK Parts is our DID platform, and it is in the scope of in the universe of ZK Parts, you don't you could do anything without your wallet address but your registered name. Look at this picture. Could you see this picture?
Yes, we can see it.
Okay, and please look at this picture, and you can see that if someone, I will go through the progress. outside our EZK pass, we always transfer Mina transfer funds by transaction, which can be chased on by our by Explorer, right? And then we, if you transfer or transfer money to someone inside our ZK pass, you don't need to worry that your wallet address could be chased by the Explorer. Look at here. Think of that Mike and Daniel will deposit their money into ZK pass Snap, and ZK pass Snap, and Mike register a name Mike.id, and everyone will register his own name. And when Mike wanna transfer Mina to Daniel, he just need to transfer to Daniel ID instead of Daniel's wallet address. All the activity happens based on the registered name. So based on this feature, you could find out it really protect our privacy, and because we could register our personal data like name, so it is actually a distributed identity platform. It actually acts as a identity passport across the ecology of Mina. In the future, when many snaps comes out, you could use ZK pass as your ID to participate in all the snaps. So let me introduce further, and let me go through the pages. Because of the time limitation, we did not carry out all our pages, but so I have to share these pages to make sense, to clarify our idea. Firstly, if you are a new user to enter ZK pass, you could fill your personal data here. For example, your name, which is unique among ZK pass, and your email, your some of your public keys, like one of the public key is for withdraw your Mina. The other public keys is for is intended for other activities. When you fill all these inputs and register, and it may trigger browser wallet plugin to make a signature, and then you could register your own name in ZK pass. And besides, furthermore, when you wanna modify your account information, you also need to log on first, by browser wallet plugin too. And when your signature and the signature is validated by the Snap, and the browser will redirect you to your own page, and then you could see your existing information here, and then you could modify your information to newest version, like email is store public key and authentication public key. but your name cannot be changed anymore because it is unique. And for example, now Mike wanna deposit some funds into ZK Pass platform. He could firstly he log in ZK Pass platform, and then he could deposit to the ZK platform. For example, for example, if I am Daniel, I will fill this input like, I could like Mike.bit, and I will fill the amount and then click the deposit, and the money will be sent to ZK platform, and ZK platform will record this transaction. Will record this transaction. And will record this amount of Mina is for Mike.bit. And when Mike.bit is logged on, he could see how many Minas is available, which includes the Minas from Daniel. And then he could withdraw his Minas to any of its wallet. You could see on the page that we could fill on these two inputs and then click deposit, and we'll withdraw some Minas from ZK platform. And according to progress, you could see that among ZK.
Sorry to interrupt, Coulstar. Maybe since we're running low on time, maybe just like 30 more seconds, if you could wrap it up. Thanks.
Oh, I'm so sorry. I cannot catch up with you because. Let me go ahead first. Why?
Yeah. Just finish up in a half minute or so. Thanks.
Okay. You could see that I just present this progress, and these are the features of a wallet. You could see that no one could trace your wallet address, your real wallet address, if someone send Minas to you by your name instead of your wallet address. And so it protects your real wallet address from expropriation, because all the transactions are by name rather than your wallet address. So it increases our privacy, right? And let me talk about let me go talk about our code. You could see.
Maybe we can just if you could leave some notes in the chat about the code, just so that we have enough time for everyone's presentations. But yeah, thank you so much, Coulstar and Comdex. Really interesting. I think someone said in the comments, it's like a combination of ENS and Tornado, which is really cool. And yeah, the single sign-on is a really cool idea also. So yeah, thank you so much. Super interesting. Would love to see this one when we have snaps on mainnet. Awesome.
Okay, so it is my time is over, right?
Mm-hmm.
Okay.
All right. Thank you.
Okay. Okay. And if someone is interested in our idea, please contact us. Our GitHub address is here. I will paste it in the chat room. Okay.
Awesome. Thank you. Okay. So next up is Carol, and Carol also has a well, slightly different, but another sort of approach to privacy using a coin tumbler. So Carol, welcome you to the stage.
Hi, I'll try to be kind of quick. So yeah, as mentioned, I was working on the idea of CoinCat Tumbler, kind of Tornado Cash on Mina. I don't have much to show in the case of UI and graphical interface, as yeah, I kind of wanted just to kind of prove the concept. And due to lack of my some of my understanding of the, I guess, SnarkyJS and the API, I wasn't able to implement everything functionally. But I think with incrementing of SnarkyJS development, that should be easier. So yeah, so that's the UI. So the snap, I called it jar of pickles. And it basically works like a tornado cache, so it allows user to insert his tokens, and then after a while, after all the other users also deposit, the jar is closed, and then it allows you to claim from different address. So how I've implemented it, basically I'll just quickly run through the code of kind of the interactions and the snap itself. So firstly, as a very interesting thing that the on-chain sequencing is going to be supported, because that was one of the kind of roadblocks for me, especially at the beginning. So I came up with the whitelist addresses that you upload to IPFS. And then that whitelist address is allowing users to deposit their coins in the order of the whitelist. So that's happening at the beginning. So owner of the snap creates a whitelist, and that can be happen on the UI or possibly on chain in the future. It uploads this to IPFS. I retrieve the hash of it in order to store it on as a state. I had to do some workarounds to get it as a decimal. So the owner updates whitelist with the hash of the whitelist IPFS hash. And then users are able to interact and deposit in the order of the whitelist, and deposit their address together with a secret number, which is then used, should be used within the claim function, and to prove that that person did actually claim the deposit. There's no public key passed anyway to the deposit function, as long as you pass the signature and you prove that you are the user that is on the whitelist. So quickly to the code. I had to store quite a few things. The IPFS of the whitelist, the index of the next user from the whitelist, the value. So for now, the kind of coin tower works on the one fixed value, and every user have to deposit the same amount. Quick boolean that it's ready to be claimed. So that would mean that every all of the users from the whitelist deposited. And then my take and kind of my try to implement the Merkle trees, which I also use on with IPFS. So initially, just initialize the values. Basically, the whitelist have to happen kind of either separate in UI or on kind of different process. So I can abstract it from the snap. But when the whitelist is ready, the owner of the contract uploads the IPFS hash and uploads empty Merkle tree to the IPFS, and that allows deposit function to be open when the whitelist is set. So that is the function that the users would interact, depositing their coins. The logic goes as they have to have the IPFS hash of the whitelist, so that have to be shared with those users. That IPFS whitelist list is getting fetched from IPFS, getting parsed, and the index of the state on the chain is used to verify the order, so there's no multiple deposits happen at the same time, because that will mess up the Merkle tree. When that's done, we increase the counter, and then we update the Merkle tree. That is just pseudocode, but basically, if I will sort or I will listen fully how to use the data store IPFS, SnarkyJS, and the Merkle trees, I hope we could make that better. And then there's one other check that checks if it is the last user from the whitelist, which would unlock the claim function, which requires users to have the secret hash of the secret number that's being passed with the deposit function. And if the owner proves that he's actually the owner of the public key, we can actually fetch the Merkle tree from IPFS, and we can validate that they have the leaf and the nodes, I guess, that will be required as well. The Merkle tree itself is stored on IPFS in this case. In other cases, it could be possibly the root of it could be stored, and then the users could have the leaves and the nodes to that Merkle tree. And that basically allows users to claim the token. So it kind of works like Tornado Cash in kind of similar way. Obviously, with the amazing announcement today, I think there is much more potential in that with how the SnarkyJS progress. But yeah, that was just a kind of concept to show what could be possible, I guess, in the future. But yeah,
perfect. Thank you so much, Carol. Yeah, it's cool example that uses things that SnarkyJS doesn't really support very well now. So it's great to highlight that. But so we will have like first class support for off-chain storage with IPFS or something like IPFS, maybe not IPFS exactly. And then and Merkle trees also will be more like deeply embedded in the library. Yeah.
Makes sense.
So awesome. Thank you so much. I think when you're doing something like using a Merkle tree, we'll need to have like the hash, all the hashes in the circuit.
Okay.
That's like the
one
piece
it's verifiable. Yeah.
Yep.
Sense. Yeah. Totally.
Yeah. Perfect. Thank you so much.
Thank you very much, guys.
All right. So our last presenter for today is Jack, and Jack's going to show Mastermind, and we actually had a couple Mastermind submissions as well, but yeah, Jack is going to present that. So thanks, Jack. And then right after Jack, I will talk about. I'll give some shout outs. So anyway, thanks.
Oop, okay, wait. There we go. This is really weird. One sec. I have like a thing that pops up in the way of my ability to share my screen. I think it's a part of my browser.
Yes, you may have to give permissions and then quit and restart the browser.
No, I have it wants to put it like picture in picture. Let me see if I can turn that off. Otherwise, let me see. Okay, if I can't sort this out in like 2 seconds, I'll there we go. Okay, sorry, I don't know what that is. I'm using like a browser called Vivaldi, and it's super weird. Okay, so can you see my screen?
Yes.
Yeah.
Perfect. Okay, so I made a Mastermind, which is a game where there's a person who generates the code and a person who guesses the code. And the person who generates the code effectively chooses 4 little like pegs of, one of 6 colors. And they don't tell the person who guesses the code. So then the person who guesses the code, guesses the code. And the person who generated the code and knows it gives them hints using black and white pegs. So if they have guessed the correct color in the correct place, they get a black peg. And if they've guessed the correct color in the wrong place, they get a white peg. So if you get all 4 black pegs, you've won the game. If you get 0 pegs, you have guessed none of the correct colors. If you get 1 white peg, it means you have one of the correct colors, but nothing's in the correct place. If you look at my code here, first we just deploy the contract and we set the secret code when we deploy it. So it's 1, 2, 3, 4 here. And then I have the ability to this first move thing is just a method that allows you to guess a code and not get a hint back. So my plan was to have this like pay out some sort of reward when you call this method. Then you have the ability to validate a guess, which is just basically a process of committing the guess to the chain. It does things like checks to make sure you've signed the message, make sure it's your turn, make sure you're one of the players. And then we also have the ability to generate the hint and to prove that the hint we've generated is correct. So this is, in this case, I actually pass in the secret and the guess. So this is because I ran out of time. Obviously, ideally, you would get the guess from chain state, but I ran out of time, and I figured it was more important to implement the logic around figuring out if the guess is, basically generating the black and white pegs in a provable way. So if you guess like 1113, if the secret code is 1113 and you guess 1131, you get 2 black pegs because the 2 ones are in the correct position, and you get 4 white pegs because you have all the correct numbers. If you guess, exactly the correct code, you get 4 black pegs. And if you guess, 444 and the code is 1113, you get nothing because all of them are wrong. So most of the stuff here is pretty simple, not very interesting. But the one thing that I did kind of do, badly, but also interesting and might be sort of worth highlighting is if you see this part here where I generate the hint, it's crazy complicated and weird looking. And this is because I wasn't really clear on what parts become a part of the circuit and what parts don't become a part of the circuit. So I kind of I think I found a way to basically force it so that everything happens in the circuit all the time. There's like no variables. And so I think this works. It's kind of weird looking, but I'd be interested in I'm sure that there's a way to do this that doesn't look this way. But as I tried to do it in other ways, I found that I wasn't sure if, everything was in the circuit or not. So yeah, that's like kind of the only interesting thing about my project. So that's, I think that's it pretty much.
Awesome. Yeah, thank you so much, Jack. And you nailed it. We were very impressed with the that section and how you made sure it was in the circuit. And it's certainly something that we'll look carefully at as we're improving the API to make sure. Maybe there is a better way to do it. I mean, we didn't have that much time to review all the projects before this presentation, so we didn't have that much time to go through the details. But yeah,
my way is not great, but I'll revisit it. And also, like for me, just sort of 2 real quick things are, I think something like JSX might be, I don't know if you've used Circom, but Circom makes it really easy, and it's harder to get started with, but it's easier to catch these kind of errors. But then the other thing is, just for me, the most important thing would just be the ability to see the circuit once, you know, just to see what's unconstrained. Even if you could just have something that said, you know, these are variables that are unconstrained. Anything like that would be awesome.
Yeah, that's something that yep, I think you must have mentioned in one of the office hours, not the one I was in, but
yeah,
someone wrote it down. So we'll definitely get on that.
All right, cool.
Yeah, thank you so much, Jack.
Well, thanks, guys. Yeah, sorry, my project's kind of iffy.
No, it's great.
Bye.
Yeah, so just want to give a couple shout outs. So there's a couple other masterminds. There's one Bulls and Cows that I'm just looking at my notes here. That Pete worked on. Someone had a cool idea to use specifically Macalfo had the interesting idea of like embedding a neural net inside of a snap. The way to do that is it's actually possible and really interesting. There's a couple other DEX like things. There's a cool private voting example by Lawrence, and then anyway, I'll stop. Just looking at everything. But thank you so much. The neural net. Well, okay, just to say it, it'll be a bit slow to do something like really, really complex, or to do like, let's say like a big image. But if you have like a simple, digit handwriting recognition on like a very, very small pixelated image, something like that could totally work. Yeah, exactly. And investors would lose their minds, AI and zero knowledge combined. So, maybe, Macklemore, if you're here, maybe you can just for like 30 seconds talk a little bit about it. But no worries. Anyway, so I guess maybe Macklemore's not here, but anyway, great. Really interesting projects, everyone, and everyone who submitted. Thank you so much. Okay, well, we can wish Macklemore a nice lunch, and I'm going to hand it over back to Jason, I believe.
Yep. All right, I'm gonna screen share once more. All right, great. So we just wanted to talk about where to go from here. You've all got to experience using the Snap CLI. That's already the tool that you would use to create a production-ready snap. So you're good there, and of course, it obviously includes SnarkyJS. The Snap developers channel, as of today, is public. So that's going to be a great place to go and interact with other developers if you want to learn from each other, ask questions. And then lastly, don't forget the Snap docs.minaprotocol.com/snaps. And we recently published a new section on there about how to write a snap, which includes a lot of what you saw on Thursday and a little bit of additional stuff. And then if you keep an eye on that, we're going to continue to add content to that in the near future. So we plan to add additional tutorials. So like David's tic-tac-toe as a tutorial, and then additional different ones in the future to help people with thinking through the creative aspects of writing a snap and just giving some more practice with all that. And then lastly, we want to open up to a Q&A. If Gregor and Brandon want to join me on the stage, looks like you guys are here. And for an opportunity for everyone to ask any questions that you might have, or just give us some feedback. I think I can mention while we're seeing if anyone has any questions. So one thing that Gregor and Brandon and I were chatting about during this presentation. We would like to provide better feedback for developers too if say, someone's using an unsupported JavaScript TypeScript language construct. We could provide warnings about that just to try to make some things a little bit more obvious, improve the user experience.
Yeah, and I think I guess we briefly discussed it with Jack, but making it really clear what's public, what's private, what's in the circuit, what's out of the circuit. I think someone else had a discussion about this as well, and that's super important, I think, for learning and for understanding that your smart contract is correct and secure.
Okay, so we have a question here. When will ZK oracles be released? When do we anticipate that? We don't have really a timeline to announce for that yet. It's a work in progress. So yeah, we don't really have a good timeline to announce for that at the moment. There's one other thing. Bijan had a great example of an Ethereum bridge use case that is probably useful to mention. One of the early examples of snaps that we demoed was with Teller Finance, where a user could verify whether they have a credit score above a certain number, and this might make the most sense to people based in the US, but you could verify if your credit score is above a certain number and then have that proof without posting any personal information on the chain. And then you would have that zero knowledge proof attesting that your credit score is 700 above. And then with that data on the Mina blockchain, the Ethereum bridge would be able to see that data and read it. So you could potentially have an Ethereum smart contracts that's doing some kind of DeFi lending, and it could look for data like that on Mina, check that before it runs the rest of its logic. So, it's a world of possibilities. I thought that was a really cool use case to mention.
Yeah, and the thing that I especially like about that is it allows for uncollateralized loans. So for folks that are like in the heavy DeFi yield farmers or whatever, you'll know like whenever you lend, you have to provide collateral that's like more than the amount that you're borrowing. And with something like getting a credit score on chain, you don't need that. Cool. So I'll just pick off another question. In order. Could we have a little more explanation about the on-chain sequencer? Yeah, so there's a reason that the API doesn't support it yet. It's because we haven't done a good enough job like figuring out an explanation that makes sense to everyone. So forgive me if this doesn't make sense, but you can think of it like imagine for those that have used Solidity, there's this notion of events. For those that haven't, if you've used JavaScript, like think about dispatching an event. You can just sort of like announce something to the world, and the way that this is modeled in Mina is that it's sort of part of the transaction metadata, like what events have been fired, and because it's part of the transaction, it actually gets stored in blocks, and in Mina, we throw out history, but at least for recent history, it is in everyone's nodes, and it's in the archive node always. And actually, in the Snap accounts, there's a Merkle list of all of the events that have happened related to that account. So the Merkle list essentially gives you like a proof that, or some way that you can reproduce the what events have been fired, and you can get that data from an archive node or from another node. And then, so the way to think about this is like, you can model something like Merkle tree updates as events, saying like, I would like to, add this data to a Merkle tree. And then the first transaction that interacts with the Snap, can sort of look at all the events that have fired recently and handle all of them at once. So that probably, maybe that makes sense, maybe it doesn't. We will come up with a better way to explain it. We'll come up with a nice API, and then it will make sense, hopefully. So,
yeah, and to add a little bit more, Our cryptography team already has the design for the backend for the Mina network support for Snap for on-chain sequencing. We just need to add it to SnarkyJS. Okay, easy question here.
Maybe I can take the. Sorry.
Do you want to do the next one in order then?
Yeah, I thought I'd answer the. Is there a way to view the constraint system, even if it isn't in a superhuman readable format? So currently not, but I'll soon work on serializing circuits, and it's good feedback that would be interesting, and I'll look into it if we can make something like that happen. It's interesting in any case.
Yeah,
Perfect.
Thank you.
Yeah.
All right, so when will snaps be on testnet or mainnet? Great question. We're anticipating and aiming for early 2022 for snaps on the public testnet, and then mainnet to follow after that with the date TBD.
It's so the problem is like implementing this is hard, and if there's bugs, we have to debug them and then fix the bugs. So we don't want to be too specific with the timeline to avoid disappointing anyone.
Yeah, another thing we want to make sure is, and part of the reason we'll be flexible too is as people practice deploying snaps on testnet, more people will be exposed to using SnarkyJS, and we'll get to learn more, get more feedback from other developers. And then so SnarkyJS is in a version 0 right now, as we're dramatically changing it and adding a whole bunch of new features to it. And it would be nice to get some more feedback during testnet from other developers who have written snaps with SnarkyJS and deploy them in testnet, and then improving that and getting to a 1.0 stage before snaps on mainnet also. So
awesome. I'm just going to grab quickly. Pete asked if we find bugs, where should we submit them? Please open an issue in the SnarkyJS repo. I think that's the best spot. And please submit them. Thank you. We will definitely read them. And we've been keeping notes about all your feedback in office hours, and we're going to go through the presentations more carefully and also take more notes about things that people have consistently messing up, so that we can improve everything. While I'm talking, I'm just going to answer Jimmy's question. So yeah, there is a bug where if you call toString or toString on a field or toboolean on on a field, if you don't call that inside an asprover closure, which we never taught anyone, it crashes, and it shouldn't. It's just a bug. So yeah, it's something that we should make not crash because it's useful for debugging. Yeah, and more generally, we certainly need to have more documentation on debugging, logging, and testing. With testing, also something that we haven't, we intend on spending a bunch of time like documenting and providing a lot of examples for, and we just haven't had time yet. So, but we plan on using Jest. You can already see that in the templates, but we just don't have, we haven't made any examples yet.
Yeah. I see a good question here from Mike. Can you explain a little more about how a ZK Oracle will be different from regular oracles? What extra functionality does it buy me? So ZK oracles are a bit of a different model in that the request to the data source occurs locally from the user's machine. And doing that allows for any data that is returned to be private and local on their machine. I know when you start to think about this and you first get introduced to ZK oracles, it's a little hard to wrap your head around, well, how is that secure if it's running on the user's machine? Well, that's what ZK Oracle solves. It's kind of a elegant solution. Probably won't take the time to explain it right now, but it provides that cryptographic verifiability while initiating the request from the user's computer. And one of the things it buys you is other Oracle systems will store data in an on-chain smart contract that has limitations, and for instance, the amount of data that you might store there. And when you're running the request locally from the user's computer, not only do you get the privacy, but it's within your smart contract too, and you have that full response. You have the full richness of that data from whatever the API source is, not just the little bits that were chosen to be stored on chain. So yeah, you get privacy, and just potentially many more opportunities of rich data, and using any API source, or not just API source, but data source. So HTTPS also as well is something that we're working to support, so that you could actually do scraping of certain sites to get data as well, just to really integrate the broad, full existing internet, the Web 2.0 internet, into your Web3 smart contracts on Mina.
Yeah, and some, just to answer some follow-up questions on that. I believe, I'm 99% sure we're doing all this work in an open source repo somewhere, but I just looked and I couldn't find it. So I don't know if Greg or Jason knows where that is. We can share a link to it. Otherwise, we'll find it this week. So yeah, but you know, if you're not if you don't have a PhD in cryptography or like a similar level of understanding cryptography, it might be a bit hard to follow the implementation efforts at this moment. So, but you know, feel free to take a look. And it is all the TLS details, you know, will be exposed to SnarkyJS. That's how the ZK oracles work. So, but you'll probably want to interact with it through a higher level API, like Jason was talking about. Yeah, I think that covers.
I can maybe.
A couple of those. Go ahead, Gregor.
Yeah, I can maybe address another question by Muhammad. If you can please describe how to define variables to be public or private, and how they can be part of a circuit or just TypeScript variables. So I know that's the core thing, or one of the important things to get right when writing a smart contract. And I just want to refer to the new docs, because I really tried to explain that particular thing there, and maybe it's clear from there, and if not, I'm happy to follow up on Discord and anywhere else to explain what's public and what's private. Maybe do we have the link to the new docs already shared?
We could share that. I don't know if we have in the chat links.
So there, I wrote a little section about what is public and private.
And then also, there, you may have noticed, but there's a SnarkyJS API reference on the docs too. So if you want to dig into the internals of it a little bit more, that's a great place to look as well.
There's a question in the Q&A section by Vim. I think we already mentioned this, but we will definitely provide examples on writing unit tests for snaps, and like flesh out, you know, unit test helpers, so that you can write unit tests.
I guess as we wait for new questions to come in, I guess I just want to emphasize one thing too, which is we have a pretty obsessive focus about making snaps easy to use. So even if you don't consider yourself an expert DeFi or dApp developer, we would especially love your feedback of things that don't seem intuitive, or things that could be made more obvious, or ways that we can improve the docs that would have helped you. Anything like that that would help others grow the ecosystem, and then becomes more valuable for everybody that way.
Maybe we can wrap up in a few minutes if there's do like one or two more questions if anyone has any.
Yeah, Jack, you asked if CK oracles are developed as part of SnarkyJS or are implemented in SnarkyJS, sorry. So currently not, and maybe, yeah, so it's pretty early for CK oracles, and we will first get them working in some other way and maybe then expose them to SnarkyJS, but I can't really say in what way.
Yeah, one of the fun projects that I hope that I have enough time to spend on, but at least someone will work on it, is getting like a full scale, as Jason was saying, like an HTML scraper, or even before that though, like a JSON parser, but all in the circuit and efficient. So something that's like easy to use, efficient, and like allows you to grab parts of some like JSON data from a Web2 API in a circuit. It's going to be really fun to implement that. And yeah, I mean, feel free to like, anyone can just go and try it. No one's started working on that yet. But it's going to be hard.
Yeah.
Yeah, and actually another thing too, if there are any specific tutorials that you think would be really helpful, we would love ideas on tutorials that we could add to the docs that you might find interesting.
Yeah, I think we've had a lot of to respond to Jack's question there. We've had a lot of feedback that it may be the API is awesome and easy, but it's a bit too magical. It's hard to understand how it actually works under the hood. So we'll have to, maybe we'll trade off like a little bit less magic, or we'll have some way to view the circuit. I don't know exactly what yet. And then common design patterns. Yeah, it's so new that I don't know that I would say common, but maybe like the commitment example that I showed, the serializing state using bit masks is like a nice pattern. I don't know, Gregor, if you have anything else to say there.
Not yet.
Yeah, and oh, another thing, right? Building gadgets. Like some feedback that we've gotten really early on, and something that we definitely want to provide is just lots and lots of like cookie cutter, snippets, templates, things that you can grab, libraries you can include to do basic things like Merkle trees. But it's like we've heard it's really important that people be able to glue things together when they're building their first smart contracts. That's like a good way to get started. So that is definitely something that we're going to support. Okay, I'll just keep going. Mohammed's question, if you have a method parameter that's not a type field, it has to be anything that extends circuit value will work. So circuit value, like when you extend circuit value, you're basically telling SnarkyJS how to encode and decode data into fields, into one or more fields. So that's how it works under the hood. And you can do that with state as well. So anything in state, anything that's a circuit value, you can put into state.
So the question about building gadgets into stuff below SnarkyJS. Yeah, I think we will also build gadgets with SnarkyJS. But if there's a more efficient way to do it at some low level, we'll also do that. But yeah, both possibilities exist.
Yeah, we already have like recursive proof verification kind of built in a very efficient way. Makalfa, right now we just have mostly like numeric operations, but we'll definitely have strings. And we already have like a partial implementation of a Merkle tree. We have a lot of cryptography stuff. I think we want to, actually, I don't know if we've talked about this enough that I can say for sure, but in my opinion, it's something we can discuss as a team and with the community and whatnot. But in my opinion, SnarkyJS should include a lot, like as much as possible. I don't know if it's either like directly in SnarkyJS or in companion libraries, but we definitely want to provide like as much, pre-built, like definitely known correct tools so that people can build applications quickly.
Yeah, and on that, we would actually love your feedback to help us prioritize as well new features to be added to SnarkyJS. So if you have features that you would like to see, and we know that there are many to be added, we'd love if you can include that on the feedback link, and just as a reminder, this link. And like even if you list them out in like your order of priority of things that you would love to see, that's the type of thing that would be super, super helpful.
I'm just laughing about, based on this bootcamp, common design patterns is to mess up. Yeah, so definitely a lot of great feedback here. How people can mess up and how we can prevent it.
A lot of good learning experiences too. And zero knowledge programming is a very different model as well. So for instance, the idea of using assertions as opposed to throwing. But yeah, just some things to learn. The new model.
Best ways to debug is one question. So I just wanted to say that I don't have anything better than console logging inside the circuit, but I think that's also not so bad. And also, I would add testing your methods with incorrect inputs and seeing if they. So, yeah, seeing if you're proving really the thing that you want to prove, and when it rejects. Yeah.
Yeah, and I think, I can speak for, so Snarky, it started as an embedded DSL and OCaml that is used extensively inside Mina's like protocol implementation. One great way to debug is in these like as prover blocks, which again, we haven't really explained. You can print out the contents of variables that the prover can see. From the verifier side, they're private, but in the prover side, they actually have some information inside them, and it's really helpful to understand what the actual assignment of variables are when you're debugging circuits. So that's probably something we should make more first class to improve the debugging experience in SnarkyJS. Jack, that doesn't yet quite work. The data store like abstraction works, but the IPFS specific instance of that data store abstraction doesn't work yet. Only the in-memory data store is working. Oh, and for Jimmy's question, dynamic sized arrays. Let's see. Well, okay. So dynamic indexing, like random access, is not supported efficiently right now, but will be. It's on the roadmap. It's something that we have to change in the underlying, like Plonk 15 snark. So that will be handled. Actually, I think dynamic sized arrays. So I think for dynamic sized things, the best way to do that is to use recursion. So you can like recursively embed a proof of a specific size, because circuits are like very fixed, but recursion lets you kind of make dynamic what is fixed. And if that doesn't make sense, it's really confusing, and we need to write a lot of documentation about it.
Okay, great. Maybe we should wrap it up.
Yeah, thank you so much, everyone.
Yes, thank you so much for coming and participating. Those are great projects and some really cool use cases in there. That were great to see. Thanks, and we'll see you around in the Snapps Developers channel. And looking forward to building Snapps with you all.
Bye, everyone.
Bye. It was fun.